Welcome to Zaption Tour 9-5, completing the square. And you're going to see me use the abbreviation CTS for completing the square. And completing the square is nothing more than a way to solve a quadratic equation. So there are three boxes, and let's get into the first box right away. So the first thing I have for you is, do you remember what a perfect square trinomial is? And so I have a couple of examples for you. X squared plus 8x plus 16. This is a perfect square trinomial because it can be written as the form of, remember, x squared plus 2 times a times b plus and then a b squared. I don't know if you remember this form or not, but this is a perfect square trinomial. This should just be an a, by the way. Okay. So x squared plus 8x plus 16 can be written as x plus 4 times x plus 4. Because if you FOIL this out or use the box method, you would get the x squared plus the plus 2 times 4 times an x plus a 4 squared. So it has this form right here. X squared plus 8x plus a 16. And then, of course, you could take this one step further, and this can be written as x plus 4 quantity squared. So this is the part where we want to end up. This is the perfect square trinomial that leads us back to this. Okay, that was a long-winded review, but hopefully that made some sense to you. So let's look at the second one here. X squared plus 10x plus 25. This is another perfect square trinomial, because it can be written as x plus 5 quantity squared. Because it has the form of a x squared plus your b, it has the form of your a squared plus 2ab plus a b squared. Sorry, I keep messing that up for you. Okay, this is another perfect square trinomial. This is going to be x plus 7 quantity squared. Here's another perfect square trinomial. This is going to be x plus 3 quantity squared. So hopefully you're noticing something about each of these perfect square trinomials, because this one down here in green, this one's not a perfect square trinomial, and we want to figure out what the difference is. So take a look. Do you see the pattern here? Are you noticing that this number here is always half of the middle number, and it's always the last number squared? So do you see that? Again, this 7 here is always half of the b, and it's this number squared at the same time. So again, the number 3 is half of the b, and the last part squared. Again, this one too. 4 is half of 8, and 4 squared is the number 16. That's what makes a perfect square trinomial. Okay, you'll notice that this one is not, right? This is not, because half of the number 4 is the number 2, and 2 squared is 4, and I have a 5 there. So this one is not a perfect square trinomial. And the whole point of completing the square is to make it a perfect square trinomial, and that's what I'm going to show you how to do next. Okay, here is box number 2, how to solve a quadratic using completing the square. Take, for example, this quadratic over here, x squared minus 14x plus 16. Okay, first of all, it's not a perfect square trinomial because half of negative 14 squared is not the number 16, so that's not going to work for us, okay? But if I do graph this in Desmos, okay, which we've done many times in this class, the answers are clearly 1.255 and 12.745. And those are not the nicest of numbers, but they're still solutions to this problem. So whatever we do when we solve this, we should get these as our answer. So I wanted to give you a visual of what this was going to look like if we were to graph it. Okay, so how do we turn this into a perfect square trinomial? Here are the steps that we're going to do. First, I'm going to let 0 be on the opposite side of my equation. So I'm going to say x squared minus 14x plus 16 is now equal to 0. Why do I put the 0 there? Well, because you guys, we're looking for where the x intercepts the x. We're looking for where the graph intercepts the x-axis, and we're going to have a 0 in the y value. So that's why we put the 0 there. Okay, now let's create a perfect square trinomial. So we're going to do x squared minus 14x plus something, okay? I'm going to leave a space there because I'm going to add a number to this side to create a perfect square trinomial on the left-hand side, okay? So I'm going to move my 16 to the other side, so this would be negative 16. But whatever number I add to the left side of the equation, well, then I also have to add it to the right side of the equation to keep my equation balanced. So what I'm doing is creating a perfect square trinomial on the left-hand side so that I can solve my quadratic nicely. So you have to ask yourself, what number is going to make a perfect square trinomial? Well, if we revisit the pattern, it's always half of this number squared. So half of the number negative 14 is the number negative 7, but when I square that number, I get 49. So 49 is what I'm going to add to make a perfect square trinomial. So that must mean that 49 is what I have to add to the other side of the equation to keep my equation balanced. Now, this part on the left-hand side will always break down to x minus 7 quantity squared. It'll always be half of your b term squared. On the right-hand side, if I take 49 and we subtract off 16, we get 33. So I get 33 over here. Okay? So now the whole goal is to solve for x. Well, I can just take the square root of both sides. So therefore, x minus 7 is now equal to plus or minus the square root of 33. And then I can just add 7 to both sides. So x is equal to plus or minus the square root of 33 and then plus 7. So there are two answers here, you guys. There are two answers. The first one is the positive square root of 33 plus 7, and that's going to give us an answer. And the other one is the negative square root of 33 plus 7, and that's going to give us an answer. So we need to use our calculators for this, so I'm going to take my calculator out right now and show you how to plug this into your calculator as well, because we need to do square roots. Okay, so here's my calculator, and I want to figure out the square root of 33. So I'm going to take second square root of 33, push enter, and then add 7, and look what number I get, you guys, 12.744, and if I round up, look, it's the same exact number over here, 12.745. That's where that comes from. So this is 12.745. And then, of course, if I did this one in my calculator, I would get 1.255. So I wanted you to see that even though our answers aren't nice or pretty, we can use completing the square to solve quadratic equations. Okay, here we go, box number 3. Let's do another example of solving by completing the square. So the first thing we're going to do is we're going to get 0 on the other side. So I'm going to say x squared plus 6x minus 7 is equal to 0. Next thing I'm going to do is I'm going to create a perfect square trinomial on the left-hand side. So I'm going to say x squared plus 6x plus something, I'm not sure what it's going to be yet, is going to equal, I'm going to move my constant to the other side, so positive 7, and I'm going to add the same value to each side. I call this side the magic number because this is the number that makes a perfect square trinomial on the left-hand side of the equation. Okay, so how do I get this number? Well, it's always half of the b value squared. So half of 6 is the number 3. 3 squared is the number 9. So number 9 goes here. So if I'm going to choose to if I'm going to add 9 to the left, then I have to add 9 to the right. Now this is a perfect square trinomial, and it will factor to x plus 3 quantity squared is now equal to 7 plus 9 is the number 16. So from here, we take the square root of both sides. So I'll bring this problem over here for you. So I get x plus 3 is now equal to plus or minus 4, because the square root of 16 is just the number 4. So therefore, x is going to equal to plus or minus 4, and then subtract 3 from both sides. So there are two answers. There is 4 minus 3, and then there is negative 4 minus 3. So the answers that we would be looking for would be 4 minus 3 is the number 1, and then negative 4 minus 3 is the number negative 7. So this one was a little bit easier. Didn't necessarily have to complete the square for this one, but if we were going to graph this one, we would see that the solutions would be at negative 1 and negative 7. We will do more practice the next time that we meet in class.